As for our last class, the function as a whole is continuous if it is continuous at every point in its domain. Now, this relatively means that if I was given a function such as this, and they said when my x is coming from set of real numbers. Now, if you remember for our first class under function, domain, and codomain also, we explained relatively well what domain is and what codomain is, what range is also. Now, this as related to continuity means that all the elements inside real numbers, when tested on this limit, must produce a result. It must produce a definite result. It must, for something like this, it must produce a definite result, and that result must be what? Real. That is the meaning of what? Continuous at every point in its domain. Now, similar for this also, if I test any value, assuming it was given us as x coming from set of say natural numbers also. That is, for any number I'll be testing in natural numbers, it must all satisfy this what? Limit, this function, such that when I test it with this limit, at any point, it must what? Be a natural number. The solution must be a what? Natural number. Welcome to our today's class. Today's class we'll be looking at continuity of functions at points a, b, or at 2 points. Now, for our last class, we looked at continuity of a function at what? A point, at a single point, and that point was a, as we used in our last class. Now, this one will be at 2 points. What is continuity for this case? Now, as we've been saying, we will need what? A function x, y in this case, and we'll need a point, or we need points in this case, a, what? B. For continuity of function at what? 2 points, I'll need what? Function what? X, y, and I'll need what? Point what? A, what? B. Now, let's see how it is defined. For me to define continuity of a function, at 2 points, it's similar. I have need of these same 3 conditions. The first one is that what? F of a, b must be defined. Number 2 condition is that what? The limit as x tends to a and y tends to b of f of x, y must exist or exists. And the third condition, is what? Limit as x tends to a and y tends to b of f of x, y must be equals to what? F of a, b. Now, it means that what? Continuity defined here is what? Limit as x tends to a and y tends to b of what? F of x, y equals to what? F of what? F of a, b. And this is the definition of continuity for this case.